iCloud. Are y'all seeing the little tablet where it says chapter 17, net present value?
Yeah.
Yes.
Okay, all right, good. Okay. All right, so today we'll talk about like, part of the role of a manager is like, no, okay, should I take on, let's see, here's somebody. What's going on? Okay. All right, okay, I see it now. One of the roles is to, deciding what sort of investments to make in the company to try to generate, cash flows. And once you have to do that, you have to weigh it against like, your borrowing cost. Because whenever, firms make investments, they're always going to borrow the money to do that. All right? They're going to raise it by either issuing debt, equity, or potentially, going to the bank. Most of the time it's through issuing bonds or, stocks and stuff like that. All right. And kind of an important concept here is, stems from what we call this time theory of money here. So we'll talk a little bit about that. But first, let's go over this definition for net present value. What this is, okay, so if we make this investment and we, take into account the present value of these future revenue that you're going to get from it, and we subtract out this initial investment, how much is it worth? Okay. So the general rule, if the net present value is greater than 0, then there's a positive profit. All right. The project is profitable. Okay. All right. So let's talk about this next concept, and that's the time value of money. Okay. Well, so the basic premise is, money in the present is going to be worth more to people than money in a future date. All right. So if you think about it, $1,000 today is worth more than the $1,000 a year from now. And then, $1,000 from a year from now is worth more than $1,000 10 years from now. Okay, and why is that? Well, we need money now to purchase things, right? We need, we're hungry, we need food, we need to pay our bills, we have different things that we need to pay for. And so, money in the present that you have is always worth more in the future. Okay? And so, kind of going off of that, this is why when you go to the bank, if you deposit money with them, you're going to get interest for it. They're going to do something with it productive. All right? But in order for you to give that up, they're going to have to pay you this interest. They're going to have to pay you back a higher amount in the future, all right, in order to give this money up here. Okay, so let's start off with this concept of this way. The future value. Okay, let's look at an example. You deposit $1,000 with a bank at 10% interest per year. Okay. Well, first of all, does that make sense? The time value of money, like why it makes sense that money in the present is worth more than in the future? I think if you just think about it, like if you could get $1,000, you'd rather have it now than 1,000. And that's because there's things that you could spend it on. All right. Now, different people discount the future more than others, but everybody's going to discount it some. Even a monk who lives a very ascetic lifestyle, they still need some money or some kind of, they need, to eat and stuff like that. So they're always going to value the present just a little bit more than the future. All right. Now, some people will discount it a lot more than others, but some people will always discount it a little bit. Okay. And this is played a part like within a country or a state or whatever. Part of like the interest rates that you see at the bank, part of there's other things too associated with that. But part of it is kind of like that aggregate, discounting that people have, this time value of money that people have, like in the aggregate, kind of averaging everybody's out. Okay. All right, so let's get back to okay, we're going to talk about the future value first. So you deposit $1,000 with the bank at 10% interest. How much is this worth a year from now. Okay. All right. So what we'll do now, we'll use this formula that we use to calculate future values. We'll do this, and then from there, like we'll talk about this other thing. That is the present value of like a future sum of money here. And this present value formula will be, you know, this is relevant towards, you know, when you're making decisions on making investments and whether or not it's going to be profitable or not. Okay. And on that is like, you know, you usually do that when you're borrowing money when you think about that. All right, but let's go ahead and solve this problem right here. So erase this. All right, the formula for future value is the present value sum that you're depositing times 1 plus the interest rate. Okay. So what's our future value here? Well, our present value we said was $1,000. That's what we're depositing with the bank. Okay. 1 plus R, we said the interest that the bank's earning is 10%. So you write that in decimal form, 0.1. Okay. So what will this be? There'll be 1,000 times 1.1. Okay. So this is just going to be $1,100. All right. This is how much money you'll have, you know, a year from now. Okay. So basically what you're saying, if you're doing this, you're saying, okay, this is how much you discount like the future value. So you're saying, you know, if you're willing to do this, like, okay, you know, $1,100 is worth $1,000 now. So I'll give up, you know, use of this $1,000 like with the bank here. Okay. So that's your present. I mean, so that's how you calculate your future value. Now this seems more intuitive to most people, you know, because you're thinking about it, this future value number, present value is important too. It's really important for like what we're doing here. You know, talking about how like managers make these decisions on whether or not they want to make an investment or not. But with this, instead of like thinking about, okay, here you got a present, you know, have some present sum or value of money that you got, how much will it be worth in the future? Now, what you're thinking about with present value, you want to say, okay, this thing. You want to say, okay, how much will this future sum of money, how much is it worth in today's terms? That's what we want to think about. So we can derive this formula from the future value. Okay, let's erase that. Okay, so let's go ahead and write our formula. Future value equals present value times 1 plus R. We want to get this in terms of present value. So basically all we do here is just divide by 1 plus R. And when you do that, we have present value on one side, future value divided by 1 plus R. Okay, so this is our formula. We just rearrange this. Most people usually think about on the left-hand side, here's your present value, future value over 1 plus R. Okay, so that's the formula we use. So we want to say, okay, you know, this question we'll answer here, what's the present value of $500 in income 1 year from now? All right. And so what we'll use this present value formula. We'll use this same interest rate, 10%. We'll say this is kind of the going rate for borrowing and things like that. And we'll do this to calculate how much $500 is, how much is it worth 1 year from now. So our present value equals, what's our future sum here? Our income that we're getting? Well, it's going to be $500. And what will we divide this by? 1 plus 0.1. Okay, so that's just going to be $500 divided by 1 plus 1.1. And so essentially $500 1 year from now is going to be worth $454.54. Okay. Any questions so far?
Yeah, is that
Yeah.
is that one like the 1 plus 0.1? Is that just 1 year from now? So if it was 2 years from now, would that be a two?
Okay, yeah, that's a good question. So let's do it. Let's look at the future value first, and then we'll also do that with the present value. Okay, so let's say you left. Remember, we talked about putting money in the bank here with the future value. Let's say if it was for 2 years, how much would you have? Well, it would be your future value equals $1,000 times 1.1. But it's going to also, this amount that we get from that, it's going to compound another year because it's further off in the future. It's going to be, have to be worth even more because, you're delaying getting it back an additional year. Okay. So what you need to do is multiply that again by 1.1. And so essentially what you would have here is the future value equals $1,000 times 1.1 squared. Okay. And this is what we talk about when you have compounding interest. This is why, I always say to start putting money in investments early on because it can compound and it keeps building and building. After a long period of time, it starts to really grow really fast. Okay. And so the same thing will work with the discounting. First of all, does that make sense? Everybody okay with that? I think this kind of makes sense to everyone. Let's see here. Okay. Start from the beginning. Are you talking about with the present value or the future value? Start over with that again. Okay. So I'll do that again. All right. So we're depositing $1,000 at a bank that pays, 10% interest per year. It's an annual interest that it pays out. Okay. And so if you want to see, what that's worth after 1 year, well, to calculate this, you take this $1,000, you multiply it by 1 plus the interest rate, which is 0.1%. You put it in decimal form.
Anatomy.
Excuse me? And that's going to give you the $1,100. Okay. Well, what about after 2 years? Okay. Well, remember, after 1 year, it's going to be this $1,100, or the 1,000 times 1.1. But this is going to compound another year. You're going to draw interest on it the second year. And so when you do that, you got to multiply it by 1.1 again. Okay. And so that future value is going to be $1,000 times 1.1 times 1.1, which is just 1.1 squared. Now, what is that exactly? Let's see, like 1210 or something like this. 1,000. 1210, yeah. Okay. And then so on. If you kept it in there a third year, you'd have to multiply this amount by 1.1. Or you could say it's 1,000 times 1.1 raised to the third. All right. So the same thing happens when you're discounting a future value. All right.
Dr.
So
Glenn, quick question.
Yeah.
So if in the third year that interest rate changed, let's say it went from 10% to 8%, would we simply take this formula that you have written here and multiply that? Go ahead.
Yeah, go ahead. What you say? You're going to say you just take this amount 1210 and then you multiply it by 1.08 is what you'd have to do.
Gotcha.
Yeah.
Okay.
You couldn't just use the same formula. If it changed, which that's going to happen, it is going to adjust and fluctuate. So you would calculate for this first 2 years, and then the third year, you'd have to just take this amount 1210 and multiply it by 1.08 is what you would do.
Gotcha.
All right.
Thank you.
Mm-hmm. All right, remember we said with this $500, you know, that we're getting paid a year from now. We need to discount it from a year from now. We need to see, okay, what this is worth, the fact that, you know, having money now is worth more than it is in the future. So we got to discount this future value. And so we'll divide it by 1 plus R, this interest rate. Okay. And this is only for 1 year here. All right. So what this essentially be is $500 divided by 1 plus 0.1, which is 500 divided by 1.1, which is just raised to the 1 power. And that gives you 4.54.54. Now, what if it's 2 years from now? Well, it's even further out that you get to use it. So it's worth even less money. So we got to discount it even more. So what you'll do, this is $500 1 year. What if this $500 is the income that you get 2 years from now? Well, you take this $500 and you discount it, you know, 1 plus R to the second. Okay, you got to discount it again here. And so what this would be 500 divided by 1.1 raised to the second. And so what will this be? 500 divided by 1.1 divided by 1.1. And so it's only worth $413.22 now. Okay, so its present value is even less now. And that's because it's even further off where you get to use it. All right, the further away it is, the more you're going to discount this $500. Okay. Any more questions with this part right here? Okay, a few more seconds. All right. Okay, so now what we'll do, we're going to take this and we're going to use it and see whether or not project would actually be profitable or not. Okay, so we're going to look at 2 different projects. We're going to see if they're profitable, and we're going to compare them to see which one, you know, would have a higher return. Okay. So let's see here. Where is this at? All right, do y'all see the practice problems that we have here? Is that showing up?
Yep.
Okay. All right, so we're going to, you know, use this concept that we have for present value, and we're going to use that to solve for net present value for these 2 different projects here. All right, one project here, it costs $10,000. It's initial investment that you have to do. And it's going to generate $6,000 a year from now and $6,000 2 years from now. Okay. What about project 2 here? Well, it costs the same amount. You got to make this $10,000 investment. All right. It generates $5,000 a year from now and $7,000 2 years from now. Now, both of these projects, you know, are going to generate $12,000 of income in 2 years. All right. But as we'll see, their net present value is going to be different. That's because, you know, the further away we get this income, the less it's worth here. All right. So let's go ahead and go back to this right here. Let's erase this and go ahead and start working on this problem. All right. Okay. We said this is problem 1 here on your practice problems. Let's look at project 1 first. Okay. So the outflow is $10,000. And so like we said here, you know, when a company, when they need to make an investment, like say for $10,000 here, they're going to raise the funds here. They're going to borrow it here. So they're going to be paying some sort of interest on this. Okay. And so that's what we'll look at here with this problem right here. We're going to say they're going to have to borrow this $10,000, and using this net present value, we can determine whether it's going to be profitable or not. And so we say that after 1 year, they get $6,000 in income. After 2 years, they get another $6,000 in income. So let's determine this net present value here. Okay. All right. So what is that? Well, it's going to be the present value, the total present value of these 2 years here, minus, this initial outlay, which is $10,000. So what we need to do is determine the present value for the $6,000 in 1 year and the $6,000 2 years from now. So let's do that first here. Okay. The present value 1 here will be $6,000. And remember, we have to discount this. This will be 1 plus the interest rate. And the borrowing cost here, or the cost of capital, this is what they have to pay out on bonds or like dividends of stock, or if they're borrowing it from the bank. Their cost of capital here, their borrowing cost, is going to be 12%. Okay. So we'll write this in decimal form. 6,000 divided by 1 plus 0.12. Okay. So this is essentially going to be 6,000 divided by 1.12. And when you do that, what you'll get is this $6,000 that this company is receiving a year from now. It's worth $5,000, $5,357.45. Okay. All right. What about the present value for the money 2 years from now? So they're getting $6,000 again. The difference here in this case is it's 2 years from now, so they got to discount it more. All right. So this is going to be, raised to the second power here. All right, representing 2 years out that you're getting paid. So you got to discount it twice essentially. All right. And so what you'll get in this example here, for this income that this company is receiving 2 years from now, it's worth $4,000, $4,783.16. Okay. So what is their net present value here for project 1? Well, their total present value of income here, this cash flow that they're getting here, what it's worth in present value terms, it's $5,000, $5,357.45 plus $4,783. So, sorry, $4,783.16. Okay. That's their total discounted income that they're getting. All right, what's this net present value? Well, we need to know whether this is worth it or not. So we need to, all right, how much are they, what's this initial investment they're making, this initial outlay? Well, we said that was $10,000. Okay, so you add these two together. What you'll have here is $10,000, 10,140.61 minus 10,000. And so your net present value here in this case is $140.61. So what would happen? This company made this investment. They borrowed this $10,000, at a rate of 12% interest. And they received, this income, $6,000 a year from now, $6,000 2 years from now. If they did this, essentially what they would have by the time they pay off, you know, whoever they borrowed this from, paid them back, you know, whatever the principal was, and also the interest there. And by the time they got this income, they would make a profit of $140.61. So it's, you know, it's a positive profit. All right, so it could be potentially something they do. But what you want to do here is you want to compare it to this other project. You have this other project that you could potentially use to spend this money on. So you want to say which one's more valuable. Okay, so let's go ahead and just write down the net present value for project one. We said it was 140.61. All right. Now we want to do the same thing for project two. Okay, and for them, you know, they're getting $5,000 in 1 year, and in 2 years, they're getting $7,000. All right, so the present value of these two income streams is going to be a little bit different. All right, the first one, we need to discount this $5,000, and we need to discount it by 1 year at the borrowing cost. This cost of capital is 12%. And when you do that, we'll see that it's worth $4,000, $4,464.29. Okay. What about the second? What's the present value of the second amount of income they're getting 2 years from now? And here they're getting $7,000. They're getting this income 2 years from now, so they need to discount it more. Okay. So that's 1.12. It's going to be raised to the second power because we've got to discount it over 2 periods here, 2 years. And what we see with this, it's going to be worth $5,000, $5,580.36. Okay, so now let's determine the net present value. All right, we want to add these two, the present value of these two income streams are getting $4,464.29 plus this $5,580.36. Okay. And we want to subtract out, you know, this $10,000 that they initially had to borrow, you know, to make this investment. Okay, and when we do that, add this part up as 10,044.64 minus 10,000. So the net present value for project two is going to be $44.64. Okay. And so essentially, you know, if you're a manager, and if both of these are equally the risk, at the same level of risk associated with it, you know, you go with project one because it's going to earn a little bit more money, a little bit higher profit. Now, I'm not so sure if you actually want to do that for only $140, that amount of money, but you know, just to make things simple, this is what you would choose out of the two. You choose project, you know, one, because it has a higher net present value, it's a higher level of profit. Okay. Any questions on that? Time, if somebody has a question, let me know. This will give you time to write down anything that you don't know. All right, so kind of what we're going to go to next. We'll talk briefly here and we'll do a problem kind of associated with it. All right. And then, as you know, we'll talk about risk. And we're looking at, okay, you have these different probabilities of these different returns that you're going to get for an investment or some sort of project that you're going to do. All right. What you do, you have to weigh these according to the probabilities, and like, you know, you can come up with what's called like an expected, you know, income that you expect to get from this here. All right, so we'll talk about that now. So erase this. And kind of the easiest way to talk about that is saying, you know, there's a coin toss and you get a certain amount of money, whether it's heads, certain amount, whether it's tails. This is usually the example that people use to kind of start off with this problem. All right, so we're going to talk about risk. The expected value of X is going to be 1/2 times $1 plus 1/2 times $0. And what we have here is we have a coin toss. Essentially, if it's heads, you get $1. If it turns out to be tails, $0. Okay? So you flip it. Each of these have a 50% chance, right? So you got to weight them, by a 50% chance there to calculate this expected value of this coin toss here. And so what you get here in this case, 1/2 times $1 would give you 50 cents. 1/2 times 0, 0. So the expected value of this coin toss is going to be 50 cents. Right? So let's look at this choice here. We're going to talk about this in potential where you can take straight up, pay a given amount of money, or you can do a coin toss or something where it's going to be 50-50, two different amounts here. And we'll kind of do this to kind of illustrate, like risk aversion and all that. And then we'll go to look at, an investment and how to calculate like how much an investment's actually worth. All right. So here you're going to be given choice A or choice B. Choice A, you get $55,000. Choice B, right? You do a coin toss. If it's heads, you get $100,000. If it's tails, you get $10,000. Shoot, $10,000. Okay. So what would, let me call someone. Let me just call the first person on this, like Daniel. Which one of these would you take?
Um, yeah, I don't know. I'd probably take the 55, I guess, because it's guaranteed.
Okay, because it's guaranteed, right? You would take
Yeah.
the 55. Let me call on somebody else. I'll just go to the last name on this list. Deja.
Hello.
Hey, which one would you take?
I'll take the chain A.
You would take the given 55,000. Okay.
Yeah.
So what we're going to see here is like the expected value and this actual value here, they're going to be the same thing. But if you're risk averse, all right, you're probably going to take 55,000, all right, because you're worried. Okay, what if its tails only get 10? It'd be great to get this $100,000, but this 50, I'll just take the sure thing with 55,000. So let's calculate the expected value of this choice B here, and what we'll see is it's actually going to be the same thing, but it's two different, choices though. They're not the same thing, even though the expected value is the same thing as value as the choice A here. Okay, so there's a 50% chance you get $100,000. And there's a 50% chance you get 10,000. So what we're going to say is this is 50,000. 1/2 times 100,000. 1/2 times 10,000 will be 5,000. Did I actually start recording this? Oh, I did. Okay, great. I did report it. Good. All right. And so essentially here, the expected value of this investment here is $55,000. Okay. Well, the expected value and the actual value of choice A are the same thing. They're two different choices though, right? Because like, there's more risk associated. There's a higher standard deviation associated with this. And so this is something you got to keep in mind. If you're making some sort of investment, a couple months later on, if it's risky, all right, well, you're going to, need to make sure that it's a higher return here when you're doing that. So if you're comparing two potential investments and one's riskier than the other one, to take on the more riskier investment, it needs to it needs to make it, not just more, but a good bit more than the other one, depending on how risky it is. Okay. All right. So it's just a short little going over the concept of risk here. All right. So next, what do we want to do here? We want to calculate. That's right. Do number 2 here. Let's do that. So let's see what this chat is. Okay. All right. Let's go ahead and see. Well, I can do it real quick. Yeah. So let's go ahead and do this practice problem number 2. This with risk. I'll do this real quick. You should be able to see it right here, number 2. So we're looking at an investment that has potential to earn $10,000 with 25% probability, $15,000 with a 40% probability, and $18,000 with a 35% probability. So what we're going to do here is find the expected income from this investment. Okay, so we'll set this up the same way, but it's a little more complicated, right? Because there's three potential outcomes. So let's go ahead and do this to give you an example to show. You set it up the same way, similar, but now you got, instead of 2 possibilities, you got 3 different possibilities. All right, so let's go back to our drawing pad here, tablet. Let's erase this. This is question number 2 here. All right, so essentially we have this investment. Return and the probability of each of these returns. You get 10,000 with a 25% probability, 15,000 with a 40% probability, and 18,000 with a 35% probability. Now, when you're doing these, your probabilities always need to be equal to 1. 0.35 plus 0.40 is 0.75 plus 0.25 is 1. All right? You need to have every potential possibility that you have here. And so this covers it. So let's calculate what this is worth in expected value terms. All right, expected income here, you're going to set this up the same way. What's the probability of investment 1 that you get at times actual value plus the probability you get the return 2 here, and its value times that. And then we also need to add in this other possibility with this probability times the value that you get for this investment if you get that return. Okay. So P1, that'll be 0.25 times the return $10,000. So the 25% chance you get $10,000. 40% chance, so 0.40, you get $15,000. Right? And lastly here, there's a 35% chance you get $18,000. Okay. All right, so what we'll do now is just add these up, multiply and add them up. 0.25 times 10,000 is 2,500. 0.40 times 15,000 is 6,000. And lastly here, 0.35 times 18,000 is going to be 6,300. You add all these up, and in expected value terms, this investment is worth $14,800. Okay. So that's how you calculate, the expected, income or expected value of a given investment here. Okay. So what are we going to do next? We're going to talk about something similar, but this is another way that, first of all, any questions on this? Sorry, got to ask. Any questions on how you do this? Give you all a second.
Professor, what's the name of this
Yeah.
formula again?
Excuse me?
What's the name of this formula again?
Oh, it's expected value. So you're using it to find the expected value of an investment here.
Okay, thanks.
It's called the expected value. Yeah. All right. Okay. All right, so now we'll go to this last part. This is where, this problem is kind of complicated. There's a problem in your homework, so, hopefully this will help you get to this. But another way that, people will calculate, managers will calculate whether an investment's worth their while or not. Instead of using net present value, they'll use what's called an internal rate of return. All right, they'll find out, okay, we have this investment we're going to make, and we're going to use this internal rate of return. And this will tell us, okay, what's the break-even point? And they're going to calculate this internal rate of return. And if their actual borrowing cost to raise, this capital is less than that, well, then it's, a positive profit. If it's more than that, if the cost of capital is more than what this internal rate of return, well, then they would lose money if they took on this investment, so they wouldn't do it. Okay. Now, so first, let's talk about, the guidelines for, trying to decide what sort of investments you're going to do, how you're going to move forward when you're making choices between your budgeting and everything. And so let's just mention these guidelines here really quick. Okay, guidelines for managers that are doing this, deciding, okay, what sort of, how are we going to do our capital budgeting? We're looking at this. So you're going to do it on an incremental basis. Which means you don't look at it, you don't look at it as just one. Now the problem we're going to do kind of simplifies it, and there's only one investment. But you got to look at it. Okay, we're going to make another investment. Okay, how much, how much more revenue you're going to get because of this? How much more cost you're going to do? So you do it on a marginal basis, like each investment. Like there may be potentially 3 investments you want to make at the same time. So you got to do them individually. You want to find out which one's the most profitable. Do that one first. Okay. What about this other one? Okay. So how's this going to change? How's this going to change the income I bring in? How much more costs are going to be associated with it? And then if you had a third one, you got to see, okay, well, how much will this one bring you? How much money will this bring you? How much more profit? You don't do them all together. You do them on an individual basis is what it's essentially, the point of this. Now, in this problem that we're going to do here, this last problem, well, there's 2 parts of it. There's only just one investment that you're talking about. It's kind of simplifying things. But if you're actually doing this for a large company, you're going to have several different investments at the same time. And so you do this on a marginal basis. Next here, another thing you got to remember when you're doing this, all right? You got to calculate everything based off, after tax, right? After tax using the marginal rate. Any profit that you make, right? You got to pay taxes on it. So when you're thinking about these future cash flows that you're getting here, even before you discount, you got to think about how much am I getting after I pay taxes, all right? Because that's what's important here. Okay. Now, kind of related to taxes here is you need to think about any indirect effects. So what are these indirect effects that we're talking about here? Well, one of the things that's important is capital depreciation. And so what you can do here, there's different ways to do it. We're just going to do a straight line depreciation for this problem we're doing. What you can do is you can deduct this from your taxes. Like, I bought this capital, it's lost value. And because of that, this lost value, I'm going to use that and I'll get to pay less taxes as a result of that. So it's going to, lower your tax burden. And the reason they do this is another way that the government, they want companies to make this investment, kind of spur on, spending a lot of times, like, cause the economy to grow. Let's see here. We got a question, I think. Yeah, it's incremental, but it's on an incremental basis. Yeah. Let me write this a little bit clearer. Incremental basis. Okay. And that's just saying each potential investment you're making, you gotta weigh them individually. Right? You don't just say, okay, I'm gonna make these 3 investments. Do I got a positive profit? Okay, then I'm gonna do it. No, you gotta weigh them one at a time. All right, I'm doing this one, then I'm gonna add another one. Well, with this additional one, how will it impact me? And if I do this third one, what kind of sort of change will it do? You gotta weigh them each individually. Okay. All right. Fourth, we're not going to talk about this much with our problem that we're looking at here, but sunk costs. You completely ignore these. All right. So what are some examples of these? Any sort of lease. If you're stuck with this lease for a certain time period, when you're trying to calculate, how you should go about with your business, you just ignore that when you're making any sort of investment. Should I do this to add a kitchen, or should I buy a new oven? You're going to completely ignore these because you're paying that anyway. Okay. Another thing you ignore is your license, a liquor license or any sort of license like that. You've already paid it. You can't get your money back. So once your business is started, you just completely ignore these sunk costs like this. Okay. Now the lease, once it's up, it's no longer sunk cost. Then you include it in your operating costs when you're deciding whether you want to keep running or not. But while you're in the middle of this lease, you don't ever consider it when you're making any sort of decision, as far as like making an investment or not. And the license is another example of these sunk costs. 5, opportunity costs. Okay. Basically, what an opportunity cost is like anytime in econ. Okay, if I'm a simple way to think about this is like, okay, if I'm deciding what I'm going to do on Saturday night, do I want to go to the movies with friends? Do I want to go? Let's see, go somewhere else. I'm trying to think, art museum, something like that. Anything, you're making these choices. When you go do one, what's your opportunity cost? Well, obviously you're paying money to go do that potentially for the movie or whatever, but you're also giving up. That is, your opportunity cost is giving up going to do this other thing. So if you go to the art museum, your opportunity cost is, well, now I can't go to see the movie, right? When you're talking about this with, like with us here in this situation is, well, your opportunity cost is, okay, I'm spending this money to make this investment. What am I giving up? I'm giving up some other potential way to do something with this money, right? Maybe I want to invest in this type of equipment. Well, I'm giving up investing in expanding, the office or adding some new software, computers. So you always think about that. You got to compare, these potential other uses of these resources that you have, right? Okay. I have this, warehouse space. I can use it, with my business, but on a way, or maybe I don't have to necessarily use it. What about if I lease that out? So you got to compare these. So essentially, if you decide to use it for your business, your opportunity cost is the opportunity to lease it out to someone else. And so you want to compare those and see which way it's more valuable. You're always thinking in these terms. If you're like, a manager of a firm, trying to decide what you do with your spending and the different resources that you have available. Okay. Any question on these guidelines? Number 4. Okay, number 4. That is sunk costs. All right. This is essentially money that you can't get back. There's nothing you can do to get it back. You got to pay it anyway. So when you're making decisions on how to, like, you know, potential investments or things to do with your business, or like if you're running the business, you're just going to completely ignore these when you're making a decision. Right? If you open a restaurant, you have a liquor license. When you're deciding what you want to do with it afterwards, once you pay for this liquor license, that's it. You're not getting that money back. So you don't ever use that when you're trying to, you know, decide on what you want to make a decision on, like any sort of investment or what you're going to do with your restaurant. Okay. It's the same thing with a lease. Like if you're stuck with it for a year, if you're 6 months into it and you're trying to decide what you want to do with your business, you know, you just ignore it because you got to pay it anyway. All right. So any sort of business decision, you're going to ignore this sunk cost with this. All right. Is that good? Any other questions on these 5 guidelines here? Let's see. Okay, no problem. All right, so let's get to this last thing that we're going to do. We'll do the first part of this problem, which we'll call number 3. Let's go look at this first. Switch over to that. Go. And this is looking at this internal rate of return. You know, we'll talk about internal rate of return, kind of, you know, get the concept first. Let's do the first part of this problem here, find the net cash flow. Okay. So Tesla plans on spending $770 million in an expansion of a Texas car and battery factory. It will generate an additional $600 million of revenue for the company over the next 3 years. The company will use a straight line depreciation to $0. So what that means is, this $770 million for like capital equipment that they've used to get this expansion, they're going to use a depreciation. So essentially, they're going to take a third of this value for over 3 years here, and they're going to deduct it from their taxes. Okay, so you got to consider this too when they're deciding, when they're making a decision whether they want to do this or not. Okay, and these additional operating costs, if they expand here, all right, for the labor, you know, any sort of electricity, any sort of resource, any sort of raw material, anything like that, will be an additional $100 million per year. Okay. And additionally here, the company pays a marginal tax rate of 25%. So we got to include that as well. Okay. All right. So what we want to do here first is we want to find the net cash flow for each year. And then once we find the net cash flow for each year, we can use that to determine, okay, what sort of borrowing costs do they need to break even? And then we can decide whether, you know, if they can get it below that, they want to go ahead with the decision. If it's higher than that, then they definitely don't want to do it. All right, so let's find the net cash flow first. Well, did it? Okay. All right, are we back on the sketchbook pad?
Yeah.
Yes.
Okay, good. All right. All right, let's erase this. Let's do number 3 here. So number 3 here, there's going to be a $770 million, you know, initial outlay. They're going to need to borrow this amount to be able to expand this this factory here. Okay. They're going to use a straight line depreciation. over 3 years to $0. Okay. So essentially what they're gonna do for each of these years when they're doing their taxes, they're gonna deduct a third of this $770 million. They're gonna say, okay, I've lost this value, this money that's spent here, you know, I wanna be able to deduct this from taxes. And like I said, the reason the government does this is that they give this kind of tax break here to try to encourage these companies to make these investments to expand the economy and grow it. Right? So we need to include that as well when we're trying to calculate this. And lastly here, marginal tax rate, 25%. That's what they're going to be paying on this initial revenue that they're getting in here. And I forgot, yeah, also the operating costs. Man, I write sometimes. The operating costs are going to be $100 million per year. Okay. All right, so let's find the net cash flow for each year. That's what's important. Okay. How much additional actual income they would actually get, you know, after we pay taxes. You know, they need this to determine, you know, what sort of internal rate of return we need here to break even. Okay, so let's write the formula first here. So what this is going to be, the net cash flow is equal to the revenue minus the operating costs okay. We're also going to, you know, we need to take out this depreciation. Now, the way they set this up to me implies intuitive, but I want to do it here the way that's done in the book, the ebook that you have, you know, so that way it kind of matches up with that. And what we have to do is we have to take out our tax, right? We're going to get taxed on all this. And we also need to include the depreciation out here. So this time we're adding it. Now let me erase that. Let it clear. Plus the depreciation. Okay. When you set it up this way, it's going to, you know, be the same thing essentially as like, you know, deducting this from your taxes, whatever this depreciation amount that you're using. All right, so let's fill this in. The net cash flow. All right. We're going to say it's $600 million per year for revenue. I didn't even mention revenue equals 600 million. That's for each year. That's how much it's going to generate. $600 million each year. The operating costs are 100 million. Okay. The depreciation is going to be 770 million divided by 3. Remember, we're going to, you know, straight line depreciate it all the way to $0 over this 3-year period. And now we want to take out our taxes. And we said that was at a 25% rate. Okay. And now essentially what we want to do here, we want to add back in our depreciation out here. Now, to me, it makes more sense. There you go. Let me write out the actual number. That actual number is 770 million. You know, to me, it makes more sense just to do, you know, 600 million minus 100 million times 1 minus the tax, and then add in, you know, this 770 million divided by 3 times 0.25. That's essentially what you're going to save on taxes. But they have it set up this way because that's the way they do it in the book, the ebook that you have in the example. So I'll do it that way. All right, now let's calculate, you know, what we have. So essentially, this is inside here. 600 million minus 100 million, that's 500 million. How much are we, you know, using for depreciation for the year? 256.67 million. All right. Multiply this by 0.75. And then also add in shoot, divided by 3. Add in 256 million.67. Okay. All right. Now what we'll do is just finish with our calculations. 500 million minus 256.67 million is 182.49 million. Add in this depreciation that you did of 256 million. And what you have for this problem is a net cash flow of $439.16 million. Okay. All right, so that's the first part of this problem. Okay. Any questions on this?
I got
Mhm.
something different for 500 million minus 256.
What did you
I
get?
got 244 something something.
What did I do here? Let's see.
243.33.
Well, then when you multiply it by 0.75, what do you get?
Oh,
You get the same thing then?
probably what you got. Yeah. Okay. Sorry.
Okay.
Thanks.
No, that's fine. No problem. Yeah. No, there's a lot going on with it. Yeah. So it's got you got to keep things straight. It's easy for. I was like, well, did I make a mistake? Because yeah, they're easy to. Yeah. So essentially, what you're doing here, you're saying, okay, I got this revenue coming in. I have to pay taxes on it, but I only have to pay taxes on my profit. So I take out the operating costs. Okay. And additionally, on top of this, I can, say that I'm losing value on this investment that I'm making. I can use this depreciation, write it off. And this gives me some additional income that I get to keep here. And so that's what you're doing. When you do this on the whole, on the net, your net cash flow, it's going to be 439.16 million. Okay. All right. So that's number 3. Now, what's it wants to find? It wants to find, okay, what's the internal rate of return for Tesla's investment? That is, what sort of break even, cost of capital, if we did this, will make us where we break even and get $0 here. All right, so let's talk about the internal rate of return here. Let's see here. Right. Let's erase this. This is probably the more challenging thing today. It's a little bit kind of hard to explain sometimes too. All right. So the internal rate of return. So I'll kind of go over this, here initially, and then I'll talk about it in terms next where it'll probably make more sense in this problem that we're doing here. And I'll kind of explain it a little bit different. And to me, the second way probably makes a little bit more sense. All right, so the IRR, internal rate of return, this is the discount rate that equates, your present value with investment. All right. Equates the present value of future income with investment. Okay. So this little symbol here, trying to work too much about it, what it represents is a summation over a time period. So you're starting at time period 1. Let's say, n is equal to 5. So this is over a 5-year period. Okay. So you're trying to determine, you got this cash flow coming for 5 years, what sort of discount rate or what sort of borrowing cost will make it where you break even. So we have this net cash flow that we have for each of these years, and you got to discount it. Okay. Right? This net cash flow could be different for these each year. But here in the problem that we're going to do, it's going to be the same thing, right? It's going to be 430 something, 439.16 million. Sometimes it's going to be different though. And here, also remember, the further out for this, the more you got to discount. And so what we're wanting to find here is, okay, these net cash flows that we're getting, that we're discounting, when's it going to be equal to this net investment that we're making? And so what we're going to try to determine is, what will be this discount rate that'll do this? Okay. When we determine what this interest rate here is, this internal rate of return that makes it break even, if it's greater than the cost to raise capital, you accept it. It's going to be profitable. Okay. But if this internal rate of return that you calculate to break even, if it's less than the cost of capital, whatever it costs for you, to raise this, then you should reject. It's not profitable. You should reject this investment here. Okay. Another thing here before I get to the problem, and I'll explain this again. I think the next go around here will make a little more sense. They rearrange this in terms of like an annuity and what it needs to be, and like this is what the table from this ebook that you have that it would be useful for when you're doing your homework problems. So they take this formula here, the summation of these net cash flows that you get each year, when you discount them in present value terms, equal to your net investment. What you can do here is you can put this in terms of a dollar annuity. Okay. And so essentially what you're doing here is you're dividing both sides by the net cash flow for each year. And so what you would have here would be your net investment divided by your net cash flow each year. Okay. And so what you have here, this is the present value of a dollar annuity. We're going to say N is equal to 5 for 5 years. Okay, so let's say this, the net investment divided by the net cash flow is 2. Okay. What you need to look at is, okay, you're getting paid $1 each year, right? A year from now, 2 years from now, 3 years from now, 4 years from now, 5 years from now. Okay. Now, what will make this be break even? All right, so what discount rate can you use here? And this totals up to be $2. Okay. And when you calculate that R, that's your internal rate of return. And we're going to use this table in our book here. And if you put it in terms of this annuity, it can tell you like what this internal rate of return is in this case. Okay. All right. So this may be confusing. Let me just go ahead and talk about this in terms of this problem that we're doing. This may make a little more sense. Then I'll stop and ask if there's still any more questions or confusion on it. Okay. So this is the last thing we're doing. We got plenty that don't feel afraid to ask questions because we're going to get done way early. So, and this is probably the hardest problem on your homework here. So, doing this. So let's go ahead and erase this. And what we're going to talk about this in terms of our problem that we're doing here with Tesla. Okay. So we need to see, we've got 3 future cash flows coming in. All right. We got our net cash flow coming in for 3 different periods. and we gotta discount it, right? Because we're borrowing this and we gotta pay this back. And this is the way we, the way we do this, we're gonna discount this amount here. So what we wanna do though, we wanna find what this break-even point would be here, right? Where if you added up these net cash flows and you discounted them at a certain rate, what would cause you to break even, right, with your net investment? Okay, so let's write this down in terms of our problem. We're looking at it, think about it in terms of 3 years. Okay, start off a year from now, 2 years from now, 3 years from now, we get the same net cash flow. And what did we determine that was? It was $439, 439.16 million, sorry. All right. And we're interested in finding out what discount rate, when we discount this for either 1 year in the future, 2 years, and 3 years, we add them up, would be equal to our net investment of $770 million. Okay. All right. So, you can also think about this in net present value terms. This may be a little more intuitive for you. So if you think about this, what we're doing here in net present value terms, all right, we would add up, of course, our discounted cash flows. All right, subtract our 770 million from it. And we want this to be equal to $0. This is our break even. All right. And so if we calculate whatever this is, it's internal rate of return. That makes it so where you add all these up, you discount them by this internal rate of return we have. When this happens, when we subtract the 770 million, it's going to be equal to 0. This is going to be our break even. This is our internal rate of return here with it in this case. Okay. Does this make sense? Any questions on this? I know this is kind of.
I don't
It's a little
understand how to like use that symbol mathematically, but I trust you're gonna, show that as we work through it.
Okay. So yeah, I want to write it out in full here in a second here. But do you kind of understand what we're doing though? We're trying to find this rate of return where if we discount these future cash flows, it's essentially going to break even. Does that make sense? Yeah, the summation is kind of tricky too. I'll write that out here in a second when I rewrite this again.
Okay, it makes sense. The principle makes sense.
The principle makes sense. Is everybody good with that? I'll give everybody, if anybody has anything.
Yeah, got it.
Just good? Okay. All right. So let's rewrite this again. All right. Already have this on that. Okay. So we'll rewrite this again. T is equal to 1. 439.16 million divided by 1 plus R to the T equals 770 million. So essentially what this summation is, what we're doing here, because this is over 3 years, so we'll write this out. This cash flow doesn't change, so it's going to be the same thing for each year. Another way you could write this is 439.16 million divided by 1 plus R, whatever the discount rate is, the first power. We got to add the next year, year 2. 439.16 million. And we got to discount it. But now we got to discount it even further, right? We got to discount it to, for 2 years. Right? Because it's even further away that we got it. And so, it's going to be worth even less money. Lastly, this net cash flow that we're getting 3 years from now. And so we got to discount this even more. Right? And we want, whatever this R is, this internal rate of return, we want it such where we're discounting we get this to be where it's break even, where it's equal to $770 million, which is that, you know, this is the how much money we borrowed for the investment here. Okay. Any questions on that? Does that make a little more sense what we're talking about with the, you know, with the symbol? You know, the symbol could be kind of confusing. Try not to, you know, they use it all and they have it in the homeworks on it, show it. But this is essentially what you're doing here. You're like looking at, okay, we're adding these 3 periods up, starting off with period 1, you know, going to the 3 periods, 1, 2, 3. All right, and so this is what we have. This is we got to determine our present value of this cash flow 1 year from now, add it to the cash flow of this present, put this in present value terms, this cash flow 2 years from now, and then add this last one here 3 years from now. Okay, and we want this to break even to be equal to that, and that'll give us our internal rate of return. Okay. Now, what you can do here, let's rewrite this again. We don't have any questions. What you can do is you can rewrite this, write it in terms of this dollar annuity. You know, look at this value that you have, and then you can like look up this table and find it. Now, this problem that I'm doing here, the cable doesn't go high enough. What I'll do is I'll give an example here, you know, after I kind of show what you do here, and like talk a little bit about like whether you want to make this investment or not based off these, you know, the cost of capital that you have. But let's go ahead and rewrite this again. All right. So basically what we're going to do, we're going to divide by 439.16 million, both sides here. And so now on this one side, we have this a dollar annuity that you have. Okay. And so we need, okay, you're getting $1 a year from now, 2 years out, 2 years from now, 3 years from now. What rate of borrowing cost here would cause you to break even with this ratio of 770 million divided by 439.16 million? And so what would determine that to be in this case is 1.753. Okay. So now let's go to our ebook. Any questions on that math there that you did, that I did? Okay. So let's go to desktop. All right. So if you go to your Mind tab, I'm already on here. I'm still here. What you want to do, let's hide this. I can't see. There we go. All right. Go to your book. That comes with your Mind tab. Go to your table of contents. Go to chapter 17. You know, we're evaluating and choosing investment projects to implement. This is where you want to go, like you want to read about this a little bit more. Okay. And so if you get this in terms of this annuity, where you want to go to like try to, you know, see what this is, and what we're going to find out is this value that I have is a little bit too low. It didn't show up. Their internal rate of return is going to be higher than what they go to. But I'll do an example also in addition to this, where we actually use it and show you how you kind of estimate, because the value is going to be in between these values that they give you. So you go to A4. Okay. Here is the present value of annuity. You have all these different rows here. This will be if there's annuities for 1 year, 2 years, 3 years, 4 years, 5, and so on. Okay. All right. So ours is going to be for 3 years, right? So let's find our value. Well, It's not here, it's lower than that, it's 1.753. That only goes down to 2.486. Let's see, let's go here. This goes even further. 3 periods, 2.44, so on to 2.10. So basically ours is lower than this. So this internal rate of return that you have, it's going to be above 20%. Okay. And so essentially what I found it to be was like, I had to calculate it a different way, was the internal rate of return is going to be 22%. Now we'll come back to this in a second. I'll finish with this problem from Tesla just to try to explain, what this means when you get an internal rate of 22%. So let's go back here again. All right. So I determined what would give you this amount here. So if you're adding this up, 439.16 million, you get this 1 year from now. If you discount it by 1.22, that is a 22% internal rate of return. Add this cash flow 2 years from now, discount this for 2 years, and then add this last cash flow, and you got to discount it with this internal rate of return 22% for 3 years. This will cause you to break even and be equal to 770 million. This initial amount that you have to borrow that you make to make this investment here. Okay. So remember what I said, if the internal rate of return is greater than the borrowing cost or the cost of capital, it's a positive profit. If it's less than the cost of capital, then it's going to be negative. So let's say if the cost of capital is equal to 15%. Okay. Would this be positive or negative profits? Someone answer here.
Positive.
Yeah, it's going to be positive. And the reason for that is, okay, you're paying less interest than, you can break even when you're paying 22%. So now that you're only paying 15%, well, you're going to get even more in present value terms revenue generated. So it's going to be a lot more than the 770 million. Okay. So this is going to be positive profits. Now, on the other hand, if the cost of capital is 25%, okay, well, the borrowing costs are more than what this internal rate of return. So you'd actually have negative profits in this case. Let's see. All right. Okay. So before we move on, any questions with this? Conceptually, what's going on with this problem? We'll finish up. The last thing we'll do, and I'll let y'all get out of here, is I'll use an example here, and I'll say, I'll give some numbers where you can actually use this table and this formula that they use here, where you can actually calculate it, because you'll need to be able to do that for your homework. But any questions on this, anything conceptually, the math, anything before I move on? I'll give y'all a few minutes.
Question.
Yeah.
For as far as the midterm goes, will we, are we going to have to do this with the math, with the table and everything?
Internal rate of no way.
Okay. All right.
It's just so the person that set this up, it kind of makes sense. I think they wanted to have some challenge stuff, like, because this is kind of on your job, you have to do something like this. But I think they realized too that a lot of people, it's been a while since you've done any of these major math, and so the exams are set up where they just want to make sure you kind of understand these concepts. It's kind of what they're going to be doing with these midterms. There will be some math. I'll let you know what all you'll need to know. All right, nothing like this. This is pretty complicated. All right. Last thing before we go. let's do an example. And what we'll do here is we'll give an example where if we calculated this, it's something that we can actually use this table for. All right, where is my example here? All right, let's say when we did this problem, that this ratio between this ratio between the net investment when you divide by this net cash flow for each year is 2.38. Okay, so it's a little bit higher than what we got, which means this internal rate of return is going to be lower, which means that I actually, we can actually capture it on this table that we used earlier here. Okay, so now let's go back to our ebook, this table that we have there. Let's go here. Desktop. Okay. All right. So I have it on here. I'll let somebody, we have 3 periods here that we're doing it. And its value is 2.38. So what we have to do first is, it's going to be between 2 values, between 2 percentages. Can somebody tell me what that is?
Going to be between the 2.401 and the 2.361.
Yep. So it means it's going to be between 12 and 13% will be our internal rate of return. All right. Okay. All right, now we want to get a precise measurement of this. Okay. So let's write these. We need these numbers too as well. This is between 2.401 and 2.361. We'll write these down. You can't see it yet, but when I go back here, you'll be able to see it. Does everybody understand what he did there? Let me go here. So 3 periods, and you look for this value that you have for this $1 annuity for this to break even. We said this ratio that we have is 2.38. And so 2.38 is between these 2 numbers right here. All right, so we know the internal rate of return is going to be between 12 and 30%. Now let's calculate the exact amount, because you have to do this in your homework. And this will be it. Okay. All right. So like I said, we had this annuity. It pays out for 1 year from now, 2 years, 3 years from now. All right, if we add this up, what sort of discount, when we discount these future values, put it in present value terms, would total out to be 2.38. Okay. Well, we use this table, and we saw that, because the 2.38 is between these 2 numbers for 3 years, and what it gave us for that is going to be between 12 and 13%. All right. So now let's find the exact amount. So we know it's at least going to be 12%, so 0.12. But we got to add something to it. Okay. All right. So what you want to do here, and what you're doing, you're kind of estimating it like percentage wise, like how far between it is this number between these to get your percentage. So this top part, all right, how far away is the 2.38 from 2.40? So we just subtract 2.38 from 2.4010. Okay. The bottom part, what we want to do is we want to get the total difference here between 2.401 and 2.361. Okay. And, honestly, you could probably just, go ahead and just put 0.01, but like what we're doing here is like, okay, this is the difference here between, you know, these two numbers. It's going to be a distance of 0.01. And what percentage of that, and then we get what percentage of this it is. This will tell us how much we need to add on to the 0.12. Okay. So what is this? It's 0.12 plus how far away is this 2.38 from 2.401? Well, it's 0.021. Okay. Well, we want this in percentage form. So we want to say, okay, how far, you know, what's the difference here between 2.401 and 2.361? And what we got for that is this 0.40. And so as you can see, look at these numbers, it's about halfway in between, right? This 2.38, it's kind of about, you know, halfway in between the 2.401 and 2.361. Okay. So basically when you multiply that times this 0.01, when you add all that together, that's going to be 0.12 plus 0.005. And so your internal rate of return, if you see have a problem on your problem list for your homework, and you had these numbers, what you would have is an internal rate of return of, you know, 0.125, or you can write it, you know, as 12.5%. Okay. All right. Any questions on that? This will be the last thing we do here. So if you have any questions, you know, please ask. Or if you have any other questions about anything else, you can ask as well.
So just to summarize, we would find where it lands on the table, you know, find where it lands in between those 2 points,
Yeah.
and then use this formula to find out exactly what it would be.
Yeah, like how
what the rate
far,
would be.
basically what it's saying here is like, well, it's 50% of the way, you know, it's kind of like halfway in between these on this problem. You know, the 2.38 is kind of halfway in between 2.401 and 2.361. That's what this little formula here does. Right? And so how much you want to add to it? Well, you know, that's the difference between 13% and 12%. So you're going to end up adding half of like a, you know, 0.001 or whatever. And then when you do that, it's adding like a, you know, like a 0.5% basically to, you know, the 12% here.
Okay. And is that the same formula that they use in the book?
Yeah, it's the same formula. I try to follow, like, you know, everything they have, so that way, you know, when you go back, it'll kind of match up with what you're doing.
Okay.
And so that's,
great,
yeah, it's a
thank
big thing too. Make sure you use your book if you're, you know, a little bit confused about this. Like I said, I'll make this recording available too as well. But, you know, make sure to use the book too as well.
Excuse me, Professor.
Yeah.
Yeah, so can you show us again which part of the book can we find the table?
Oh,
I know
okay.
it's chapter 17, but I don't know which
All right.
section.
I'll go through that again. And I'll go through the steps again. Yeah. You know, for this one, we had like 3 periods, 2.38. All right. So let's go back to the desktop. All right. So here's your mind map. You come over here, look for this book, go to your book, get it open, go to your table of contents. This is what we did today was from chapter 17. Click on chapter 17. Here we're evaluating and choosing investment projects to implement, you know, using the internal rate of return and all these other things like, you know, where we estimate the cash flow, this as well here. Okay, so here it talks about your internal rate of return. It talks about, you know, converting it where it's in terms of a dollar annuity, where it's going to break even between this ratio. And so once you do that, this number that you get, you go here to 8.4. It's an appendix A. It's table 4 essentially, in appendix A. Click on that. Expand this. Here, this is how many periods you're looking at. Remember we said it was 3 periods, and we had a ratio of 2.38. And this doesn't go down low enough. So we need to, our internal rate of return is gonna be higher than 10%. So we come down to here. And it's essentially, we have 3 periods. We had 2.38. So we go here. Well, it's higher than that and lower than 2.401. So we know that it's between 12 and 13%. But what we need to find is the actual, percentage, like how much more to what percent do we need to add? And so that's why you use that formula. And since 2.38 is kind of halfway in between there, it's essentially going to be 12.5%. Okay. Let's see.
Thank you.
All right, so we have some questions here. Yeah, you have to. You do have to purchase it. So is anybody still having trouble getting access to it even after they purchase it? Forest resources. It's still not letting you access it, even after you've done that. And okay, still doing that. All right. I'll look into this further. Maybe I thought I set it up correctly, because it's maybe something's going on. I wish I was there and that I could. All right, I'll get in touch with you, John. Anybody else is having these issues, let me know too as well.
Yeah, I was gonna say, sorry to interrupt, Professor. We could talk.
Yeah. So some people aren't having problems, some are. So this is okay. All right. So anybody that's having issues, send me an email so I know all the names. Because sometimes you have to talk with the lady of Denise at the bookstore, and she has to straighten things out. But potentially maybe it is something I meant. But some people are getting into it, some aren't. I don't know. It may be something to do with the access code. Okay. All right. So that's what I'll do. I'll look into that because you need it now to do this homework.
Yeah, I do have a question about
Yeah.
that.
Yeah.
How do we access the homework on MindTap then?
Oh, okay. So I'm still here on the screen. So let's lock this out. All right. So it's from chapter 17. You'll click on where it says organizational architecture regulation, chapter 15, 16, 17. Go down here to chapter 17. And you'll click on here, this part that says counts toward your grade. And you got 3 problems.
Okay, thank you.
Yes, like I said, everybody that's still having problems, please send me an email so I can have your name. If I can't figure out what's going on, I'll contact Denise. Sometimes she contacts you or she tells me something I can do, or give y'all a number to contact somebody. Or sometimes she contacts that's engaged. Hopefully we can get this straightened out and really quickly because you need to get access to this. Okay. All right. If there's anything else, let me know. Oh, there's a bunch of messages. Okay, let's see. You should be able to go to Shop Akron's zips.com and buy it. Same message. Only the links circled work for me. Yes, same. All right, Erica. Send me an email, Erica. So that I can, give you exact instructions on how to buy it. And anybody else is having issues, please contact me. If there's nothing else, then y'all can go ahead and enjoy the rest of your evening. Also, if you hadn't turned in your homework, please do. I'll start deducting because I'm gonna start grading tomorrow. I'll, if you don't have it turned in by tomorrow when I start grading, I'll deduct 20%. I'll still take it. So please do it if you haven't. But I'll start deducting once I start grading and giving people, showing their grades.
We just
Danielle, yeah.
fill it out in that box, right? Fill it out in the box but it had me attach something too for this week's homework. Is that fine? I mean, I just typed it up or whatever and.
Yeah, you can type it
attached
out in that little assignment box. You can write your answers in it. Yeah, I'll go to it and grade it. Yeah.
Okay.
Danielle? You have a question, Danielle? Okay.
Hello.
Yeah, Danielle, yeah.
Okay. So for the homework last week, I did it on paper and just took pictures and uploaded it.
Oh, that's
to
fine. Yeah.
Okay.
Yeah, as long as I can see it, that's fine.
And then another thing about the homework, I think it was the last problem.
Yeah.
It was like I used what we did in class, but what we did in class didn't seem or what I did from me copying what we did in class, I don't think I got the right answer. So I ended up looking it up and like the equation was like percentage change of Q over percentage change of P. I don't have it in front of me right now, sorry.
Yeah, that's a formula, yeah.
With that formula, when I looked it up, it said in like the denominator to have, I think it was P2 plus P1 divided by 2. And I didn't.
Yeah, you could just eliminate the twos because the midpoint, because you got them in both numerator and denominator. But yeah, that is the midpoint.
Okay.
Method,
Well,
yeah.
I guess if I did that for the homework and I think I got it right. But
If you set it up right and maybe you calculate something wrong, I won't count off too much. Yeah, I'll give plenty of credit.
okay.
If you set the problem up right and like you just have a math area, I'll just count off, a small percentage of the grade. I'm not gonna kill you too bad on that.
Okay. Well,
so say if you set everything up right, you just made one math mistake, it'd normally be 20 points or say whatever. I think it's 5 problems, 20, whatever. I'd count off like 5% for that. Yeah.
okay.
Anything else for anybody?
Yeah, I kind of struggle with that same problem. I almost felt like, I'm sorry, Junior, but I almost felt like I didn't have all of the information to be able to find midpoint, so I kind of like got halfway there, I feel like.
Oh, okay. Well, I'll look and see what you have here. Yeah,
Sorry, can I speak?
from now going forward, you can. You may have asked me some questions. I can't remember, Josh. Did you? Because I had several people ask questions about it. Yeah, if you're having issues like that, feel free to send me an email. I'll usually get back with you within the day, and I can, if you're having, especially with math, I know it's been a while for some people. It can be kind of challenging, and so don't worry too much about it. If you set it up right and you don't get it all the way, I do give partial credit. Okay. All right.
Can I?
Let's see. All right. Okay, like I said, if anybody has anything, please send me an email. So these messages are on here, but like it's easier for me if you send me an email directly. If you're having trouble with MindTap, please do that. And if you have some questions once you start your homework, please email me. I'll kind of work you through what needs to be done. Okay. Otherwise, I'll see y'all next week. Hopefully, we'll be back in a classroom. This was no fun doing this for a long class like this.
Can I ask more question?
Yeah. Go ahead.
The homework that's in the MindTap.
Yeah.
When you go into it, if I click on one of the questions, once I'm in it, do I have if I got out and didn't finish it, does that count as an attempt?
So what you want to do is when you do an attempt, you want to make sure you grade it now because you get 3 attempts.
Yeah.
If you
So-
go to
so-
the end and say to grade the whole thing, you won't get a chance to get your 3 attempts. So make sure when you're doing, you know, let's say if you answer some problem here, grade it now. I got 0.5 out of 3 here. But
Okay,
you
so
get another attempt.
as long as I don't hit graded now, I can keep.
So grade now is fine. You keep doing that in front of the reversion. But if you continue on to another problem,
Yeah.
and then you know, say I'm done, calculate my score or whatever,
Yeah.
like submit assignment now, then you won't get your other attempts. So say
Okay.
if I was to click,
Yeah,
I'm
but-
done, submit assignment
Oh.
now, you wouldn't get your 3
Well,
attempts.
Yeah, what I'm asking is if I started and I don't finish everything, but I want to get out and come back, would I have to grade it? Right.
So what you
right
want to
then?
do, no, just save it, don't grade it.
You
Yeah,
save it? Okay. Okay.
save it, don't grade it.
Okay.
Yeah. Because sometimes people will start it and you start again. Yeah. Yeah. Just make sure you don't, you know, say you're done. Because when it does that, it'll calculate everything added together and that'll be your score. You don't want that.
Okay.
All right. Good. All right. So I'll see everybody next week.
Thanks, Professor.
Thank you.
Yeah.
Thank you.
Thank you.
Mm-hmm.
Thank you.
Let's see. Stop recording.